Today we have a MDTools demonstration. I have made a small diagram, so we'll try to design a manifold mounted on a hydraulic motor, a variable displacement. So this is just a small sample of application. I had a 3D model of a hydraulic motor. It's a Bosch Rexroth axial piston variable motor. I used the version with a hydraulic displacement variation. So it is a minimum and maximum displacement controlled with a hydraulic pilot. So I controlled with a reducing valve and a directional control valve. We have two counterbalance valves, keeping the position, the load. The application could be a winch, although this is not even close to a winch application. And we have a shuttle valve taking the pressure to do the hydraulic pilot. Although I have made the diagram in HydroCAD, I'm not using the Hydro to MDTools. My intent here is to show how to design with MDTools without starting from HydroCAD diagrams. So let's first look at the diagram. So I took a snapshot and we just define a bit of entities here. So just to understand the schematic, we have A and B port connected to the counterbalance valve, and we go directly to the motor. And we take the shuttle valve, we have the counterbalance valve, and the pilot is going directly to the valve. So we will need to name these different nets. So net in MDTools is a group of ports that must be connected together. And so slowly during the design, we will give names to this kind of net. So the net is basically all the ports connected together by the same group of connection lines. Let's start. So let me go to Inventor. Last webinar was made with SolidWorks, so today I'm using Inventor, and next month I will switch back to SolidWorks and again. So we start with a new part. Everything we do in any case is doable with the SolidWorks version also. And I switch on my MDTools 780. We will slowly build the assembly at the same time. So let me also, let me open the motor. So my motor was a Rexroth, and it was a A6VM. Just to understand a bit how our manifold will be assembled here. So this motor has rear flanges, and those are 1-inch code 62 flanges. And let's measure the distance. So this would be the distance between our flanges, so 84 millimeter. We will try to make our manifold here, and we will put on top the NG6 valve, and then we'll see how the manifold is going. So we remember now this 84 millimeter, and that will be our starting point for the design. So let's go back to our part, and we start with a block. The block will not be very large. Let's make it 200 by 150 by 100 millimeter, then we can change it as we want. So our manifold will be assembled to the motor. So on this side, we expect to have the two code 62 flanges. So let's go to our cavity library and search for a 1-inch code 62. And let's say that this is our motor A port, and the net name, let's call it MA. We can give net name whatever we want. So this is the A motor side, MA. And we put it here. So we rotate the flange and position, let's say here, 60, 70 millimeter. We do the same for MB. That's our MB, and the component is MB, and we position on the same face, rotate with a reference to this cavity at, we remember, 84.0. That's the distance. So our actually we need to assemble this manifold to the motor, so we cannot have the bolt holes here. We will need to replace our bolt holes with just a pass-through. So we take a pass-through M12. Those are M12. and we replace, and we do the same here. Later we will put the drills on the other side, M12 as well. If we want, we can put the drills, otherwise we simply stretch the drill opposite. Usually people then like to have a counterbore on the opposite side. Later we will add if we have time, otherwise we simply stay like this. We stretch the drills. We need O-ring, and so this is a one code 62 flange, so we can add an O-ring groove here. And the O-ring groove, the standard, it's 41331-219. This is the standard O-ring size for this flange, and we do the same for the other. So we have also the O-ring here. Anytime we can start building the assembly. So let me save my block, and that's my manifold block. And I can build a new assembly. And in my assembly, I will position, I will place my manifold block from my workspace. This is my block. And my block will be fixed. So with a right click, I will make it grounded. And now I can place my motor. A6. That's my motor, and of course we can use the constraints that we have from the CAD application. In this case, I will make mating between faces, and then I will make center-to-center connection. So I will connect this line here with this port and the other with the other port. So this is our manifold, and now we start really building our design. Let's save our manifold assembly. And we go back to our block. So if you remember, there were two counterbalance valve. So the counterbalance valve was linked on port 1. This is nice. It's a T2A, so we can put directly opposite on the flange. Having the one port on the motor side. So we go and search for well, let me reduce a bit the depth of these drills. Let's say I just need 20 millimeter. And same here, stretch, select 20 millimeter. Then I go into my library and search for a Sun Hydraulics T2A. So port 1 is our motor A. The component is our counterbalance, let's call it CBA, counterbalance A side. Port 2 is the inlet, so the A port. So we call it A as a net. And the pilot is coming from the opposite side, so from the B side. If we go back to the diagram, we can see that 2 is connected to A. Let me change color here. 2 is connected with A, and B is piloting the same valve. The opposite will do on the other side. So there will the second valve will have A piloting 3, and then we have a B directly going to the valve. So let's go back here, and we insert the first valve, and we position. Let's put in the center directly. So we reference to this cavity at 0, 0. And we can, well, actually, maybe we can also reduce a bit the block. Let's stretch it. There is enough room. We make it 80 millimeters. And we stretch this drill. Always time to make it larger later. We can also use the match properties to copy one drill to another. So we do all and copy the same. So they are identical. Let's do the same. That's a counterbalance side B. And now it's motor B, the B side, and A is the pilot port. Insert here a reference to this cavity at 0, 0. So exactly in the center. We can see that we have a cross pilot. This is good. Let me extend these drills for some relay shortened. Let me reduce a bit this one. Let's make it 10 millimeters and extend this drill. Now we need the flanges, so A and B inlet, which are always 1 code 62. So let's go back to 1 code 62. Our flange is A, and the net name is A, and we put on this side. Let's try connecting. So we connect directly to the 2 ports. And we see that the drill is coming small, 15 millimeters, because it's demanded by that valve. We don't like it really to reduce so much the drill on a flange, so we prefer to have an initial step of the same size of the flange, like 25 by 10 millimeters, and then we'll add an additional drill internal. I do the same on the opposite side, so the net is B and B is the component, and I put it here. And I can reference to the opposite face at 0, 0. And also I can stretch this drill. Now we can start making the connection. So I can see that the yellow needs to be connected there. So I want to do something tricky here. I want just to move this port down. And I want to try to add an inclined drill going inside the port and then extend it and go in there. Maybe I will need to sink this cavity, so I will edit this cavity and change the LS to 22. Let's try with 22, and later we may change it. Now I want to make an inclined connection between yellow and yellow. So the command is angular connection. I will take my start point, and the end point is port number 2. I expect a 15 millimeter diameter. I want a simple angle. I can see a preview of the drill. I like it, and I can create the drill. I want to stretch it to make it slightly longer. And let me add a drill to the same one. We want to go on with a 6 millimeter drill, let's say 100 millimeter deep, and maybe more. Let's make it 150, too much, 140, and we put it here. So we can see that we need to deepen more. Let me just stretch, change the inclination, make the inclination higher. Let's make it this way, 10 degrees. As you can see, I need to move down my drill. I need to add some material to my block. So let's go here and stretch my material to 85. And I can move multiple, 1 and 2. And I can move down by let's say 5 millimeters. Okay, now looks better. So this is entering. If you see artifacts, you can click color, and this will color again our drill. This is doing better. I need to sink a bit more this drill. So this cavity, let's make it 26 less. This is entering correctly. If I had made it, let's say 25. So here I am touching the LS depth. So here it's a bit tricky. I could damage O-ring when assembling my cavity. We can find this problem by running the connection check. So with connection check, MDTools will find out issues. I have a broken net. It's the pink one. It's not connected. And I have this problem highlighted. So this drill, the plug 1 drill, is the inclined one, is touching the dead area of CBB, counterbalance B side. So we don't want it. We add it and sink it by 26 millimeters, should be fine. To verify, we do again the connection check, and now that issue should disappear. In fact, it's not there anymore, and we need to do all the other connections that are needed in our block. Maybe this drill can move down. And now we can add the drill to this and go directly inside here. So we can add the drill. So when we add a drill, this drill will be part of the same cavity. This inclined drill is not the same cavity. It's a different operation, of course. They have two different inclinations. In this case, I need just another concentric drill. And I need it 15 millimeter. I make it 45 millimeter deep, not enough, 50 millimeter deep. And I can click OK. And that's my drill. We can also use the connect cavity, connect to port number 2 to have a better connection in the center of the cavity. To save some space, we could also rotate this, rotate by 90 degrees. And we could probably stretch the block and make it, let's say, 195. That's okay. If you want, you can verify wall thickness distance. You can verify distance between maybe this cavity and this one. And this will give you 10.91. This is a lot. I usually don't like to measure distance. I really prefer to do a wall thickness verification. So I want to verify maybe between selected cavities. I want to verify this one with this one and with this one and start. My limit is maybe in this case 8 millimeter. Depending on the size of the drills, you can change the limit. And here you have the minimum distance. It's between these drills, 6.6. That's fine, not a threat. So I live with it. Now I want to extend this drill to go through because I need the purple connection there. If you remember from the application, we had a shuttle valve, and now we need to find a position for the shuttle valve. It was a T11A shuttle valve. It was taking the pressure from A side and from the B side and sending it to the reducing valve. If we go back to the diagram, it was here. The shuttle valve is here, was taking B side, A side, and 3 was going to the reducing valve. This is our shuttle valve, SV, and we place it, let's put it here on top and position somewhere here. Now we see purple. Okay, that's a good position. We can connect purple and maybe use this as a pivot point to do the connection with the other pilot line. I have not selected any plug for my design, so let's go to the settings and go to the export. And for my design, I need BSP plugs for sure. That's my standard. I also want SA plugs. I usually use the small SP-2, which is very small, and it's handy because it has a very, it takes relatively small volume in our design. So I want this. So now I have a list of available construction plugs in my design. Now I can start making construction plugs. So I need a plug on this port number 2, and I need, let's say, short port number 2 to position on this face. And let me move on the Y direction. Okay. And I can stretch this drill and make the connection. And now by default, my short port is not synced. There is a command to sync the spot face. It is called flush. You can flush the selection, and this will make the cavity to flush. If you always need sync the plugs, you can go to the library manager, MDTools library manager, and find your plug. It is in my library SA plugs, number 2, and I want to leave it at always 3 so that I don't need every time to sync it. Let me save it. So next time it will be by default synced. If not, if you don't like, you always edit and can change the depth of the spot face. So now we can, so this is okay. We need to connect to the other pilot line. So we need a construction plug on port number 3. We always take the short port. By default, it will take the 1x4 because this cavity is demanding a 9.5 millimeter diameter. So it takes the closest plug that can do that drill, but we need just a pilot line. So 6 is enough. And we don't want to go on top of the yellow line. This will create problems with connection. So we stay tangent. A tangent will stay too close to the bolt hole. Let's move slightly to the left. This is enough. Later we'll do some wall thickness checking in our design. And as you see now, the spot face is already synced. Although there is a small overlapping with the profile of the flange, this is not really a problem. The plug is inside the face and the O-ring is far away from the drill. Now we can copy the same drill, and let's say that we put on the bottom face and connect with the 2 drills. And now we have made a connection. We can see that there is enough space between yellow and pink. If you want, you can do a wall thickness verification, maybe around this yellow by 5 millimeter. And I don't expect any issue here. There is enough. We are doing good. We can remove some material on this side, let's say 135, and maybe less later. Let's go back to the assembly and start assembling our valve. So we go to the assembly, and we can see that our block is starting having a bit of shape. I assembled it on the opposite way. Let me update. Yes, I assembled. Let me, since it is symmetrical, let me swap. Let me delete and delete. And I want the other constraint, this one with my block, and yes, and this one with this port. Okay, so here I expect to have my NG6 valve. We can start assembling the components. There is a command that will make all the plugs. So by running plugs, we can see all the plugs assembled. So we can see all the short port plugs. And we can also assemble the components. Component, we take the T11A is a hydraulic, should be this one, CSAB. Let me check the diagram. CDAB, I should have CDAB, that's it. And the T2A, always sun. Let me search. Those were CBEG. CBE, that's the same. I mean, the shape is not changing. So CBE is the size. This is fine on the T2A, and I can update all. So looks good. No interference. Let's start adding our NG6 on top. So if we go back to the diagram, we remember we had an orifice that was entering in the P line. A was going to the X. X is external on the, so we expect to have a rigid pipe or a hose outside. So X will be a port outside our manifold, while we have an internal tank that will also have an external drain line for the motor. So we need to have 2 tank lines. And we remember the orifice. So from the valve, there will be the orifice. So for us, it will be easy to assemble and maintain the orifice from this face, from the top face of the block. So let's make a construction plug here on the port 3, the smallest one on top. And I want to put the orifice here. So I add a construction plug here. Now I need a larger one, let's say G1 by 8. That's fine for an M6 orifice. I put it somewhere here, let's say 25 from the cavity. And that's too close. Well, we could just change the spot face. That's okay. We don't care if the plug is outside the face now. We add an orifice plug to this cavity. It's an M6, and the destination net is NG6P. This is the pressure line for the NG6. The net name is really up to you. So you can, when you design without HydroCAD, you define the net name that are more convenient for you. If you design from HydroCAD, then you do whatever HydroCAD is recommending. So you don't care about net names. Of course, here I forgot to connect the yellow lines. Let's do it quickly. Let me create a construction port on item 1, short port. We put on the top face. And well, we could move it somewhere here. And we can copy it on this side, connect it. And we can connect down here. So we can copy again, put it here, connect to this drill and this one in this position. This is very close. You can also rotate. Now that may not be an ideal solution, but you can rotate the flange in this case 20 degrees. That's not really a problem. Too much. Now there is an interference, but it will allow me to make a direct center-to-center connection. Remember, center-to-center is always better connection for intersections in a manifold manufacturing. I can just stretch this drill. And actually, this drill could be made on the opposite side, because here on top, I want the NG6. So this plug may be a bit in a bad position. So I can change face position here and connect also to the one port. We make it slightly offset. And at the same time, there is an intersection. You can identify always with the connection check. So this connection check now will give me wrong connection, because the pink net is connected to the yellow. And here it is a wrong connection plug. But we don't really need to run connection check here. We are aware that there is an issue. We can just do the move multiple, 1, 2, and move to the right. Let's do some steps. And now we can just connect. And we can also reduce a bit the depth of this drill. Always here we have enough material. We can remove 130. That is fine. Let's start placing our NG6. Well, it's ISO 4401-3-2. A is our export. It goes to the pilot of the motor. B is not used. P is the what we had called NG6P. Remember, MDTools will find out the net that are already defined in the block. So we can just select NG6P, and the tank is a new net. We call it tank. That's our NG6 valve. We put it on top, and I want to have the A port on the right side of the manifold by looking this way. So let me put it here. So I can connect the pressure. Same colors means they will be connected together. Here I can see a similar color, yellow to yellow. I don't like, that's a different net. If you need to change a net color, just go to the model browser, nets. I can see A and X are the same color. Right click, change color, and I take a blue. So we put our export. It's a G1 by 4. Let's say that the pilot line for the displacement is a G1 by 4. The net is X, and we put it on the right face connected to this port. There is an overlapping of spot face. Let's move it slightly up. No overlapping. We could also move slightly left or right according to how you want. Let's stay with a 7mm diameter. No, we used the 6. Let's keep the same tool. Match property. This tool with this one, we want to copy the same drill diameter. So now that when the manufacturer will machine this face, it will, with the same tool, it will make also the other drill. B port is not needed, so we can delete it or suppress it as you want. And now we put the tank lines. It will be handy to have a tank line here. And the drain of the motor we put here, and then there will be a rigid pipe to the motor. So that was a 1/2 inch G1 by 2. That's our drain to the motor tank line, and we put it here. Let's leave it here for the moment. We take another one here. That's the tank line, and we put it here and connect with this drill in the center. That's a different cavity. Let me replace. I took a wrong cavity. That's a particular one. Let me replace this cavity with a standard G1 by 2. And this is okay. Let's say that we can do an align these 2 cavities. There is enough. We can stretch this drill up, and we add a small drill. Add drill to this cavity. Let's say we add a 6mm diameter by 80. Let's make it 90, and that's fine. And we connect it. Looks okay. Let's verify our connections. Start. No issue. So all the connections are made properly in our block. Let's do a quick wall thickness check. 5mm around all cavities in our block. There are some issues. Here, that's A, BH2. Okay, this is with the bolt hole. So let's move everything slightly. I really don't like this design made this way. Well, in any case, let's move 1, 2, and 3 by 1mm. So now we can just do a wall thickness. Well, let's measure the distance. Distance between this and this is second surface is this one, 4.78. It's okay. And we take this one. It's 3.34. So let's stay 0.5mm to the right. Move multiple. But that's enough for this application. It will be not a problem. It's a small drill, and those are bolt holes. If not, we can just make this drill. But 6 is okay. It's the same. So by the way, by doing the wall thickness, we can go through all the possible issues in our design. We need some engravings for our block. So manage, we attach an engraving to the A port here. And let's say that the height is 80 millimeter. And let's rotate it by 90 degrees. And we attach also the engraving to B port. And this will be 270. And we position it somewhere here. And we attach also here. That's our drain motor. And so on. We go back to the assembly. And now we update the drawing. We do a new plug because we miss some plugs. And now we miss also the NG6, so component. We select the 4401 selected files. In this case, we have Bosch Rexor 4W6D with ZDR6. So first we have the pressure reducing, then the directional control valve, and we update all and close. And now our block is ready. So A will be connected with the pilot of the motor. So there will be a rigid piping here. We can assemble also fittings if you have fittings like I'm doing now. So X will require a fitting, G1/4, but you could have more. And let's say that on the G1/2, we have G1/2 fittings. Update all. We could also add flanges on A and B. Let me add a couple of flanges. Accessories, flanges, and we take 1 inch socket well flange. Update. Okay, my block looks good. And the application is good. Okay, let's say that now I need to make a machining drawing. Let me save everything. So I go back to my manifold block. So today I will make a drill chart. So before doing the drill chart, I will run the machining ID command. Machining ID will assign to each cavity in the block a unique ID. And identical IDs, identical cavities in the same face will have same number and different letters. Okay, that's my style, and we start making a new machine drawing. That's my manifold drawing. I want to create the 6 views of the block, of my manifold block. I need to display the machine ID for sure. So that every ID has a unique. If you want, you can highlight construction plug with a cross. So like I'm doing here. I can put dimensions. I can highlight the flanges and footprints by adding the outline. So like in this case, it's adding, if you see some text overlapping, double click and just move the text where you want, and then close the sketch. This is for Inventor only. In SolidWorks, you just take the text and move in the view. They are not in a sketch. And now we want to make a machining chart with, it's configurable. Let me take the one that I have. And I want to place here. And that's my drill chart. Let me split it into a table, split table. And let's study it a bit. So let's move it to the left. So operation 101, there is a drill 5 by 37, there is an orifice, so the M6 by 27.8, then there is a BSP plug G1 by 8. And of course, in my style, I don't describe fully how the BSP plug or the cavity are made. I usually add some tables or cavity profiles. I have developed my own tool here, which I run now. And in this way, MDTools is adding its inventor, adding the sketches for the flange. I have a SA 6000 flange, and then I need, sorry. Inventor has changed the behavior of, so this is going to be here. And maybe the T2A. Let's move it down there. And then we can add additional profiles here. And so on. So in this case, I have made my complete machine drawing. If you want, you can display also hidden views, hidden lines. And but to do that, you must run the show command, show, yes, and this will show the internal details of the block. Now, MDTools is creating phantom hidden views of all the lines, internal lines of our manifold block. The manifold is not so complete, but has enough different aspect, O-ring and inclined cavities, plugs. So I thought it was a good example for a webinar. I usually never run this because although it's nice to have this this internal of the block, but there are viewers that help better with understanding how the block is made. So if, for instance, then I can show you something smart. So jumping across our products. If I export from our block an MBXML file and go to our manifold edge. Let me go to manifold edge. Let me sign in. So this is a cloud platform where you can share design, but let me just show you how we can view the internal of this block made here. Let's go here. Let me upload the MBXML file that I have just made. And let me view it. So this is the block that I have designed, viewed in a browser without need for Inventor, SolidWorks, or MDTools. And here I can do a lot of much more inspections, like I can view the intersections. So where the intersection is starting between different cavities, or I can make dimensional views for each single face of the block, or I can do much more. But here we enter in another product, and we'll have separate webinars on this.